An idea that shows up on the AP exam, usually on the multiple choice, but in the 2020 exam, since there is no multiple choice, one that could show up in the free response this year, is the relationship between original functions and inverse functions and their slopes. And this is something that you don't tend to see in calculus books very often. This is kind of an AP specialty kind of problem. But if you think about it a little bit, it's really just a mild extension of basic calculus with a really good understanding of the inverse functions from Algebra 2 and Pre-Cal. So first of all, be careful with the notation. I know a lot of times we think about a -1 power being a reciprocal. That's an unfortunate usage there. This is the inverse function notation, okay? And remember what an inverse function does. An inverse function switches the input and the output. So if one function has, let's say, the point 2,5, its inverse function is going to have the point 5,2, okay? And that's one of the things that's going to make a big difference in this problem. Now, there's also a connection between the derivatives of original functions and inverse functions. We'll look at that in just a second, all right? The strategy that I stress here, I am not good at doing these problems off the top of my head, but one of the really important strategies for the AP exam, the AP exam is incredibly visual, all right? And if you can make sketches of just general concepts, you can usually kind of figure out where things are headed, okay? And that's what I'm going to do here. So I have no idea what the original function looks like. I honestly don't care, okay? And in fact, sometimes I won't even worry about it matching the data, although I'm going to try to have it kind of match the data here. All right, so let's look at what we've got here. They're usually going to tell you something either about f or f prime, and then you're going to have to use that information and kind of tweak it to find out information about the other one, okay? So they tell us that we're dealing with f prime when x is equal to 4, okay? So f prime has the point 4 comma, and we don't know what the y coordinate is, okay? You switch the input and the output. So that means that this point on f prime is going to correspond to a point that has a y coordinate of 4 for function f. Well, I have a table over here with information about function f, and we can see here that this point right here has a y value of 4, its x value is 2, okay? So that's going to be the point 2, 4, okay? And if I flip-flop that point around, that'll give me the point 4, 2 on f, I said f prime, I'm sorry, on f inverse, the inverse function, okay? Now let's make a sketch of this. Remember, for an inverse function, you switch all the x and y values, okay? So for f inverse, it's going to have the point 4, 2 on it. We could go over 4 and you go up 2, so maybe something like that. And I have no idea what f inverse looks like, okay? I'm just going to make up kind of a dummy graph to give me an idea what's going on here. So let's say that f inverse looked like this. Okay, there's f inverse, just totally made up. Okay, I'm not even worrying about if it matches that data. I just want you to see the relationships here. Okay, so that's the point 4, 2. All right, f has the point 2, 4. So you're flip-flopping all of the x and y coordinates on this graph. And so the point 2, 4 would be up here somewhere, okay? And what's going to happen, that function would look something kind of like this, okay? If you remember from Algebra 2 and Pre-Cal, when you switch the x and y coordinates, you actually get a graph that's symmetrical around the line y equals x. Okay, so I made a function that would be easy to draw symmetrically around that line. It'll work for anything, but I wanted something simple. So anyway, here's the point. This point on f prime matches up with this point on function f. Okay, so notice I'm not putting in 4 to find my slope for function f, because I've got to deal with information about function f to get this down here. I'm actually putting in 2 for the point that we're looking at on function f. Okay, so you can see here when x is equal to 2, y is equal to 4, that's that point right there, the slope is equal to 5/3. Okay, so this slope right here, if I drew a tangent line in, the tangent line would have a slope of 5/3. Okay, that's your derivative, f prime. All right, hopefully you can kind of see here the slope of the tangent line here. This is kind of a steep line. If I drew that tangent line in there, it's kind of a shallow line, okay? It's not going to have the same slope, okay? And again, this is not a brilliant drawing, but it's enough, okay? Think about what a slope's definition is. A slope's definition is a change in y over a change in x, okay? Between the original function and the inverse, you flip-flopped all the x's and y's. Okay, so what's going to happen is your change in y would be happening on the bottom of the other function, and your change in x would be happening on the top. Two things happen here. The x and y coordinates change position, and the slopes are reciprocals of each other. Okay, but you've got to have the two parts on the curves that match up with each other. Okay, so if this slope is 5/3, this slope is going to be a change in x over a change in y. It's going to be 3/5. Okay, so 3/5 is our final answer. But the mistake that a lot of people make on these problems is they'll just say, oh, I'm going to go to 4 here, and I'll just take the reciprocal of that, and I'll get 9. Okay, but again, the point on this curve that has an x-coordinate of 4, x-coordinate of 4 is over here. On that curve, it would be some point that's like way up here somewhere, which has nothing to do with what the curve is doing in that position. So switch x and y, take the reciprocal of the slope. Again, even if your picture doesn't match the scenario very well, make a sketch of this, okay? You'll be able to kind of feel out those two relationships based on what they're giving you and what they're asking you to find if you've got a good picture, okay? I've got a degree in math. For some reason, I can't do these problems off the top of my head unless I have the picture. So I suggest that you do that as well, and I think it'll make a really big difference.